Hey, it's Troy again. So this is just a follow-up video to the last RAM-ROM card video. I didn't get to demonstrate the features where the paging between RAM and ROM works, and I also didn't get to update the emulator. So that's what I'll be doing in this video. So first I'll be updating the emulator, and then I'll be writing some test code, 6502, and testing it on the emulator and in the real machine. So first of all, there's a configuration file, config.h, which contains all of the constants, so various addresses and device options for the emulator. And so if we have a look here, there's RAM, RAM size, RAM start, RAM size, and ROM start and ROM size. Now each of the devices, if we just have a look at this, the main file here, so this file is a bit monolithic. I really need to go through and refactor some of it, or at least split it out into separate files, but anyway. So the emulator is built on basically an array of devices, and the devices include literally everything that's on the bus, including the CPU, including RAM, ROM, the TMS 9918, the audio, keyboard, everything is a device. And so I've got an array of devices here, and if we just have a look at what HBC 56 device is, so it's just a C struct, which contains a bunch of functions for the emulator as a whole to interact with the device. So if we go back and look at, say, a read, so there's a read function somewhere here. So memread, it goes through and iterates through all of the devices and asks them if they can read a certain address, and the first one to say yes wins. So these are my memory devices. We can create a RAM device or create a ROM device, and I think the easiest way to tackle this will just be to affect the ROM device. So we have arguments here for the start address, end address, and contents. I think if we just add in another one for the port, for the register port, and then if that's not 0, we'll assume it's backed by RAM. Easy enough. So now, if we take a look at our memory C file, almost said CPP file. So when we create a ROM device, I'll add that argument there. Create memory device. So let's look at that. I think it's fine to leave that. Yep. But what I will do is update this. So it has data. I'll add another pointer to the backed data. So I'll just call it shadowed. And then also the address of the register. Yeah, the address of the register and the value of the register. Now that's going to be the address, not the port. Okay, so when we create a ROM device, if the register address is set, and actually in create memory device, I'll just make sure we set these to 0. And I'll also add a reset function now because we're going to need it to reset that register if the machine resets. So on reset, we want to set the register to 0. Everything else is fine. Yeah, so if we have a register, and destroy as well. So destroy, we want to also destroy shadow. We don't need to check for 0 because if it's 0 it won't be destroyed, that's fine. So we shadow with the same size. We'll set the register address. And we'll set the register value to 0, although reset should do that as well. But so that's that done. So we can create it, we can destroy it, we can reset it. So when it comes time to read it, so if we've got, so if we're using banking, we'll have to check that. So we get bits 12 through 14 of the address to work out which page we're looking at. So that'll be 7,000, which is 0, 1, 1, 1, then all the zeros. 12 through 14, 12. So that will give us a 0 through 7. And then we need to get the bit of the register for that index and see if it's a 0 or 1. So yeah. And 1 shifted by page index. So here we're getting the index of the bit that we're interested in, and then we're looking at the register and ANDing the register with that bit. So if it is RAM, then we'll do this except with shadowed. Otherwise, and we'll just fall through and we'll get ROM. That's fine. So writing, this one's slightly different. It's similar but different, because remember when we write, it will always write to RAM regardless. If we got the bank address, yeah, we do need to do this anyway. If we've got the bank address, we don't care about any of that. It's just write shadowed. Okay, so that's that done. Let's switch back to the config. That'll do. Okay, and then now when setting up our ROM, here, we'll pass in, actually we need to get the full address, so that's this one, HPC 56i address. Okay, that looks to be done, unless I've stuffed something up. So now I think I should go and create a test program. And so if I open up Visual Studio Code and open up one of my existing test programs, yep. So this one will work well because it has strings stored in the ROM. So normally I can't change these. So let's test that out. Actually, I'll just run the program. So that's all it is. Okay, so if I try and write to this data here, we'll do it at the start. So we'll load character X, for instance, and then store it at text. As expected, that does nothing because we're looking at ROM here. But if I go and, so before we do anything, I'll go and copy the ROM into RAM and then set bit 0 of our register to RAM, then we should see the X. I see what we've done. So currently we can't write to the register. So let's fix that. So that's in a write. We'll check that first actually. So if address equals our register address, then the value equals value. Okay, let's try that. Still nothing. So here I set the write function to null. Can't do that. Yay! That's awesome. Okay, and just to be sure, so if I don't do this, perfect, okay. Emulator works. So let's try this on the real machine. That's good. Awesome, so we're seeing the X's in the top left corner there, which means we've managed to write to the RAM and read it back again. That's great. So that's it for this video. Thanks for sticking around to the end, and we'll see you on the next one. Bye.